Thanks, everybody. As Javier said, this is certainly more of a technical progress presentation on the software that we've been developing, and it's combining a lot of the research that you've already heard about from the rest of the MTG team in Barcelona. So I'll start with a brief introduction about what I'm talking about, and then start talking about how we're collecting data for this application. So we're collecting data from lots of different sources and lots of different communities, and we're collecting this along with corpuses of music. And as Javier talked about earlier in the morning, we've got this problem of completeness that we have to work out how complete is our data set. Once we have our data set, we're starting to run some of the analysis algorithms that have been discussed earlier by Ajay and Gopal and Sankalp. And in the end, we pull it all together into this application, Dunya, which we're presenting for the first time to the community here at this workshop. And I'll finish up with a little bit of future work on where we want to go. So Dunya is our application. It's a web application that we've developed that presents the research that is being performed within the CompMusic project. Currently, it's been developed to showcase the kinetic research that's been ongoing, but future plans, as I'll talk about, we want to extend this to the other styles, other types of music that we're working with in the CompMusic project. So I want to start just with the idea of data sources. How do we actually get enough information to show and to present to people? And so, for example, what we're interested in doing is taking information from as many different places as we can. For example, you can see here, T.M. Krishna, where might we get information about him from? Well, we could get information from Kucheri's. He has a Wikipedia page, so we might get some information from Wikipedia as well. We have lists of all of the information, all of the albums that we know that he's performed. And so we have track listings, we have titles, we have accompanying musicians. And of course, we also have the audio that he's performed. And so the role of Dunya, to pull it all together into the center here, is we want to collect data from lots of different data sources and present it in one interface to people who are interested in exploring this music tradition. So as another idea, another representation, we're pulling in lots of different information, and we're applying similarity to it. We're applying these measures. We're running these analyses that you've already heard a little bit about. We're looking at this information, at the structure of this information, and we're showing it in a few different ways. So as I've demonstrated, the Dunya browser. And of course, as Gopal alluded to in his talk, we're also interested in presenting this in a more semantic way, in a way that machines can understand it. So talking about some of the data sources that we're using, one of the primary sources that's very useful for us, and Javier again also mentioned it, is Musicbrainz, which is an online database of music metadata, including artists, concerts that are performed, or albums that have been released by these artists, including track listings. And a really useful feature of Musicbrainz is that you can also provide relationships between items in the database. So you can indicate that a particular person played an instrument on an album, and that information is very useful for us, both in terms of learning semantic information about it and presenting it in our application. A lot of this data we've had to enter ourselves. When we started, there was not a lot of kinetic music on Musicbrainz. Javier indicates there was zero. Now we're doing a bit better now. We've got about 200 albums that we've added ourselves. As we were adding them, we did find we had some problems. For example, we wanted to indicate the instruments that were performed on these albums, and Musicbrainz didn't know about them. So we've been working closely with Musicbrainz to add features to Musicbrainz that support the kind of data that we want to add to the database. So for example, we've worked with them to add more Carnatic-specific instruments. We've worked with them to add sort of more Carnatic-specific concepts such as raga and tala, which don't really exist in Western music and was not something that Musicbrainz were interested in storing. But we went to them and said, hey, we've got this data we want to store. What can we do? And we worked with them to add functionality to do that. Wikipedia, of course, I expect most people know Wikipedia, online encyclopedia of information. We're using it to get biographies and images of the artists that are currently in Wikipedia. One great aspect about this is that the text and the images are available under a free license, so we're able to reuse that in Dunya, and of course we cite the fact that we get the information from there. Musicbrainz has some semantic information related to Wikipedia, in that it says if a particular artist has a page at Wikipedia, and so we use that semantic relationship to look at Wikipedia and find biographies and find images. And in the future, we might look at using more semantic methods to explore the Wikipedia page and where it links to try and learn more. Couturiers.com, I expect, again, most people, at least in this room, know what Couturiers is. Again, an online database of Carnatic music, musicians, and a lot more. We're currently using it for biographies and images of artists, and we're very thankful to them for collaborating with us and providing us with that information. And so, finally, talking about these CDs. So we've got 287 CDs that we've added to Musicbrainz. We have a lot of metadata for the CDs, including the cover art. We've got ragas and talas listed for most of the tracks in the database, covering almost 300 artists. And we're starting to find information about these artists. For example, biographies, images, Wikipedia links. But as you can see, we've still got a lot to go. And again, the audio, a lot of the audio we've received from Chaso, who have been gracious enough to provide us with the audio for research purposes. So we're thankful for that as well. So as I said just earlier, originally there was no data in Musicbrainz. We've had to add almost all of it ourselves. And we've done the best we can, but sometimes we're not perfect. And so one of the things we're wanting to do is check that we have as much information entered as we can. For example, we may have artists who have their names spelt differently, or ragas and talas with spelt differently. We want to make sure we have images for all of our cover art for our CDs. We also want to know these relationships that I talked about. So the idea that we can list that a person performed an instrument on a particular track or in a particular concert. And so as part of the process of gathering the data for Dunya, we're checking that we have as much data as we can. And so we've developed this interface which shows a broad overview of all of our audio. And we're listing all of the releases that we have in the database along with the audio that we've found. And if we actually choose one of these particular releases, we start showing some tests. So, for example, we show a test to make sure that we have the information added to Musicbrainz and that we know which item in Musicbrainz this audio matches. We can also look at relationship information. So, for example, here's a few recordings that are in Musicbrainz that don't have works added to them. And so this interface is for our researchers to go back, and the people who are helping us add data to the database, to go back and just make sure that all of our data sources contain as much information as they can. So that covers sort of the semantic information, the textual information about about the audio that we have, but we also have the audio, and you've heard earlier today about some of the algorithms that have been developed to generate more meaning from the audio, and so that we can start doing content-based analysis on this audio. So we're using a framework tool called Essentia, which has been developed at the MTG in Barcelona. And so it's a collection of audio processing algorithms and a lot of helper utilities that allows people to quickly write algorithms that can analyze music using sort of a lot of state-of-the-art research. We've got a lot of implementations of state-of-the-art algorithms available for our use. There's over 7 years of research and development gone into it, so it's quite robust. And it provides tools for us, especially in C++ and in Python, for developing these more specific algorithms. So what we can do as part of this infrastructure that we've developed as part of Dunya is that we can write an algorithm, and we can describe the type of output that our algorithm gives, and we can also save different versions of it. So, for example, we may want to develop an algorithm that extracts a particular feature, and we find a bug in it, or we think of an improvement. And we can increase the version and say, well, now we've got the old version and the new version. And what we can actually do with this is we can use it to compare the outputs of two different versions of a data extractor on the same piece of audio. We also have access to download an API to access this information, currently available as a web API. We're using it in Dunya, and we're hoping to make it available to the other researchers at the collaborating institutions, so that they can also have access to our extracted features. So just as an example, I thought I'd give a little example about how we're writing these data extractors. This example, we have two different implementations of an extractor that determines the tonic of a particular recording. And so, for example, here we're saying it's the first version of the tonic identifier. It takes an MP3 file, and it generates an output called tonic. This implementation is actually very simple, because Essentia contains a tonic identifier for Indian art music. But we also have another implementation where we've said, we have a more optimized C++ version, and so it's an external application. And within the same infrastructure, we can call external applications and get the results from them. So to actually generate this data, we've been using our CompMusic cluster, which we run at MTG in Barcelona. We have 100 terabytes of disk storage. We're not running out anytime soon, but of course it would be great if we could collect enough audio to do so. We have a cluster of machines currently running 6 virtual machines with many threads each, and it's letting us do some really quick computation. So as an example, a couple of weeks ago we ran the final version of AJ's rhythm, or the preliminary version of AJ's rhythm extractor, and we ran the numbers, and we looked at it, and we saw that it'd probably take about 2 weeks to run over our 1900 files. We ran it on our cluster, and it finished overnight. So we find that this is a really valuable resource for us, especially in this process of writing these algorithms and developing these algorithms and getting rapid feedback. The cluster is really useful for this. So now I'm going to sort of step into the output of all of this collection of data and computation of data, and give a very brief presentation on our application, Dunya, that we've developed. We'll be doing another more in-depth presentation, Vignesh and I, tomorrow, so you can see more about how it works there. So I'll just give a very brief and point out a couple of key features of what we can do. So we're working with a web application framework called Django. Dunya itself is a web application. It's available to anybody who has a web browser. We're using modern web technologies, HTML5, which allows us to do things like draw interesting extracted information on the screen to look at. It also lets us play audio to people, so we've got a full streaming audio system. We have a relational PostgreSQL database, which stores a lot of our metadata information, and a Apache Solr database, which is used for a lot of search, optimized for fast search on text information. So pulling it all together, we've developed a culturally specific schema for this kinetic music. And so what we're doing is we're getting all of the relationships between information that we know from Musicbrainz, and we're storing that ourselves in a way that we can understand the relationships between each of these items. So, for example, we know that an artist performs an instrument, and artists plan concerts, and concerts have lists of recordings, and a recording is normally a recording of a work, and we know that a work has a composer, and it also has a known raga and tala. And so all of this information we're collecting ourselves into our database, and this is what we present in the main Dunya interface. So one thing that's worth pointing out here, if you just imagine the top of the box goes a little bit higher, is that most of this data is not, and most of this relationship information is not specific to kinetic music. In fact, in general terms, the only thing that's specific to kinetic music, and we might not find in other types of music, is the raga and tala. And so what we're actually hoping is that this general schema infrastructure is useful to extend to further musical cultures. So we'll be extending it to the Hindustani tradition in the future, and also the other styles, Makam, Beijing opera that Xavier mentioned earlier this morning. So Dunya presents two main interfaces of exploring with data. We have a browsing interface, which lets you select an item from the database and see other very specifically related items. And we have an exploring interface, which shows you detailed information about a particular item in the database, and also some more related items around it. It's online right now at dunya.compmusic.upf.edu. Anyone is welcome to try it out. We're very welcoming on any feedback you can give us, so please try. Just going back to this idea about the culturally specific schema, as I mentioned, we can see these relationships between, for example, an artist and a concert, or an artist and an instrument. And so, to give a first example of the type of features that we can provide in Dunya, is that we can actually search for a particular artist. We can search for a particular artist here and see some related information about that artist. So we can see the artist, we can see their instrument, we can see what instrument they play, or if they're a vocalist. We can see the concerts that they've performed. And so one of the features that we're really trying to do with Dunya here is pull together this information and present it in a way that's useful for people to learn more about something that they may be interested in. As another type of query that we support, for example, we're saying, we've said here, we're actually interested in two artists. What can you show us about two artists? Well, we can show information about these artists and the instruments that they perform, but we can also show the concerts where these two artists perform together. So if you're particularly interested in finding a concert where two people performed. And we have other types of information as well, instruments, ragas, and talas, and we can do more complex queries. For example, show me only the concerts by a particular person where they performed only this raga and tala. So this browsing interface lets you have a first look into the Dunya database, and then you might want to see some more information. And so we present these specific pages where we show more detailed information, including biographies, images, and all the related information that we have. So, for example, concerts that this artist performed. This is metadata that we have from Musicbrainz, but we're also going a step further, and we're, for example, talking about similar artists, which we'll explain in the demo tomorrow. But generally, we're looking at things like lineage when we see if two artists may be similar. Again, instruments. So, for example, we show images and descriptions about these images, and also people who play these instruments. We're starting to do some content-based analysis. So, for example, when we show ragas, we are doing content analysis on similar ragas, and so we're showing similar information as well. Move on to the sort of final point of what we're bringing all the research together into in Dunya, and this is the idea of presenting a single recording. And we're gathering in as much metadata and derived data, computationally computed data as we can. And so I think you may have seen some of these screenshots already in the earlier presentations. But for example, we're showing things like tempo, and on the bottom here we're showing pitch that this vocalist is singing at. So we're really hoping that this type of interface is going to be very useful to people who are looking to sort of learn more and understand more about some specific music. There have been some challenges in pulling all of this together. Especially in this previous interface. Audio itself is relatively big. Of course, we've compressed to MP3 and things like that. But more than the audio, a lot of the derived data is very big as well. We're sampling it up to 200 times a second for some of the information that we're presenting, and we're generating extracted data that's almost as big as the audio itself. So we're working with some sort of more efficient data formats for presenting the information in Dunya, and only presenting it when it's needed. So of course, if you have a slow internet connection, or if your bandwidth limited, we're taking that into account, and only showing you the information that you need right at this time. In terms of future work, we're really interested in getting feedback from the workshop today and the seminar tomorrow. We think we've got a really solid first step for our Dunya application, but any ideas that you could give us would be more than welcome, and whether you can grab one of our email addresses, or grab me or Xavier or one of the other UPF team and talk to us about that. We'd be happy to listen to your ideas and see if we can implement them using the data that we have. And of course, finally, we need more content. We've mentioned that we have about 250 CDs. We know that this doesn't encompass the entire Carnatic tradition. We need more audio. We need more information about this audio metadata. New data sources. So, for example, we're collecting information from Kacheris. We're also interested in finding data from other websites, maybe other people who know information that we can use to start learning more about these relationships between things. And we want to work with the communities, as I mentioned. We want to know how you want to use the data that we have available, and what data we may be able to use to provide more information to you. And finally, we know that the CompMusic project is not just Carnatic music, of course. We've got future music cultures that we want to extend this kind of system of presenting all of the information in a culture to people. So hopefully in the next year, we're going to start working with the other music cultures that we work with in the CompMusic project. Thank you very much.